This recording is about systems for Unit 3. So let's look at a few examples to do that will help you with this assignment. So they might ask you to graph the system. So for example, f of x equals e to the x over 4 and g of x equals 2 square root of x. And ask you to graph this. So the best way to graph it is to make an XY chart for each one and just pick points to plug in for X, find Y, and then you can put them into the same graph. Okay, so for f of x, if we plug in like 0, 1, 2, 3, and then we would just plug them into here and it answers out. For the other one, this one might be a little more strategic because of the square root. So you might pick, 0, 1, 4, 9 and plug those in. And then get some numbers out. So for the first one, we would have the points 0, 1, 1, 1.284, 2, 1.65, 3, 2.12, 4, 2.7. For the second function, we would have the points 0, 0, 1, 2, 4, 4, and 9, 6. So you plot those on the same coordinate plane and see what that looks like. So I'm just going to do a rough sketching here. The exponential would look something like this. And the other one would look like this, the one with the square root. So there you can see that system actually graphed together. Alright, another example, use algebra to solve um, 3x plus 4 equals 1 over x. So the trick here would be to multiply everything by a common denominator, which would be x. So 3x times x, and then 4 times x, and then 1 over x times x. So then we get 3x squared plus 4x, and then this one, we see that those would cancel, so we get 1. And then it says we want to solve it, so this is a quadratic, so we'd want to move the 1 over to the other side, and we get 3x squared plus 4x minus 1 equals 0, and then we would want to factor it or use the quadratic formula to solve. So this one doesn't factor, so we have to use the quadratic formula. So negative 4 plus or minus the square root, 4 squared minus 4 times 3 times a negative 1, all divided by 2 times 3. So we have negative 4 plus or minus the square root of 16 plus 12, all divided by 6. Which gives us negative 4 plus or minus the square root of 28 divided by 6. We always want to simplify our radicals, So that's negative 4 plus or minus the square root of 4 times 7. And we know that 4 is a perfect square, so we have 2 root 7 divided by 6. And then, of course, we want to reduce our fractions. And so 2 goes into all of those, so we have negative 2 plus or minus the square root of 7 divided by 3. Alright, next one is a graph. So this is a graph of a system, and then it asks what are the solutions to the system. So the solutions to the system are these points here, and the graph they'll give you in the assignment will actually have a nice grid so you can see where they cross, but just for our purposes so we can really see what's going on here. These are the two equations, and then so the solutions to this system are going to be these points. So there's 3 solutions, because solutions to a system when it's graphed is where the 2 cross. And so these 2 cross in 3 places, so all 3 of those are the solutions, all 3 of those points listed. Alright, another example. Here's a system asking you to kind of do all of it now, because one just asked you to graph it, another one asked you to find the solution. So if they said to solve the system, then I would take this and I could graph them. And so that means making a table, XY chart for each one, plotting it on a graph, and then finding where the 2 intersect. Or you can solve it algebraically. It's up to you. How you solve it algebraically is that, in this case, we would set these equal to each other. And then solve it the way we did on the last one. In this one, you wouldn't necessarily have to graph it as well, would be another way to solve it. If you just made a table of values and plugged in some numbers, you would see that they would end up with the same values on there. So like for example, if you plugged in negative 1/2 into both equations, you would find that the other number is 2, and that would actually be in both of these. So you definitely can do that with just using the table of values without actually having to graph these. But then again, it's also difficult. I might not choose negative 1/2 just off the top of my head. Alright, next one, f of x is exponential, so we have to know what that looks like. G of x is linear, so we have to know what that looks like. And then we know some more information. So the functions have these values. So f of 1 equals 2, f of 2 equals 6, g of 1 equals 2.5, g of 2 equals 4. Now the question is true or false. It follows there must be a solution to f of x equals g of x between 1 and 2. So that means that the x's between 1 and 2, we're saying, hey, there's going to be some sort of solution in between those two. So how do we know? Well, if we look at a graph with these pieces, and we look at f of x, it said that f of x is exponential, f of 1 is 2, so they plugged in 1 and got 2, and then they plugged in 2 and got 6. So about here. So this one looks like this. The other one says they plugged in 1 and got 2.5. So about right there. And then they plugged in 2 and got 4. And this one's linear, so it's a straight line through there. And as we can see, it does cross between 1 and 2. Now how would we know that? Because we see that if we plug in 1, the first one is 2, this one is higher, right? So 2.5 is higher than 2, and we look at the next point. The first one is higher. So here this one's higher, here this one's higher. So we notice that they kind of swap places, and so therefore they do cross. And here's the visual representation of that and seeing that they do cross. So just looking at those numbers, we can see that they go from, low to high, but then it's high to low. Alright, that's the end of this recording. Now you need to call, text, or Skype message me to get a couple questions about this and get credit for this assignment. Have a great day.